this lecture we will continue with our explanation of ROC analysis. In our previous lecture I have given a theory about what is the confusion matrix and ROC analysis. In this lecture I will explain pictorially what is the different types of ROC curve, how that ROC curve is used to choose a correct classifying methodology. That is, ROC can help to predict the accuracy of our regression model. The agenda for this lecture is we will continue with the receiver operating characteristics curve, then how to choose the optimum threshold value to classify the category whether it is 1 or 0. Here we will use lot of pictures give you more understanding for you. See what is ROC analysis? As I told you, the curve which I am showing previously, see this portion is abnormals, person having disease. So if you are predicting exactly it is a true positive, sometime this much portions actually belongs to a normals category. Since it is lying on the abnormal side, we have given a report saying that you have the disease, that is a false positive. Now this is the decision threshold. You see the another choice that whoever on the left hand side we are going to say true negative. In the true negative side there are some people who belongs to positive side, they are also lying on this side in the negative side. So we are going to give a report false negative. What is a false negative? Even though they have the disease, we are going to say that you do not have the disease. So what is the true positive fraction? True positive fraction is true positive divided by our false negative, this one, also called the sensitivity. True abnormals called abnormal by the observer. This is the right way, because if they are abnormal we are going to say that yes they are abnormal. False positive fraction is FPF is a false positive divided by false positive plus true negative. Then specificity, true negative divided by true negative and false positive. True normals are called normals by the observer. This false positive rate, there is nothing but 1 minus specificity. So what will happen? False positive rate, if you write 1 minus something, you will end up with the false positive divided by true negative plus false positive. The next one is a true positive fraction, TPF equal to true positive. This curve is ROC curve. As I told you, in y axis we have true positive fraction, in x axis we have false positive fraction. See the range is 0 0 because it is a probability 0 to 1, in y range also 0 to 1 1. This curve, the C curve, you see that where is a C, you see that this category, when there is a somewhat overlap between your this is a true negative, true positive. So this is the situation of your, so this C, so we can, I am writing here, so this was for this curve. You see that one, there are some more overlap, so this is the situation when the B curves. You see that there is a complete overlap, this is the situation of our A curve. If it is completely separated, both true positive, true negative is two separate curve, so you will get a perfect ROC curve. Now look at the different conditions. Evaluating classifiers via ROC curves, classifier A, this one, this line, cannot distinguish between normal and abnormal, because it is normal and abnormal, there are two curves which are completely overlapped. The second one, B is better but makes some mistakes, this situation, because there is a somewhat overlap. C makes very few mistakes, it is not completely separate. So this line, the reversed L shape, is the perfect line. So this graph, this picture connects between ROC curve and different types of your true positive and true negative. There may be a perfect category. A perfect means no false positive and no false negative. So, this line, no positive, no false positive and no false negative. Look at, there are different situations. See, ROC curve, receiver operating, or OC curve, ROC space good and bad classifier. You look at this one, this is a good classifier. Why we are saying it is a good classifier? High true positive rate and low false positive rate. This one we say bad classifier because low true positive rate but high false positive rate. This one is a bad classifier because real picture, because it is both are equal. Next, there is one more term to explain the quality of a regression model, that is area under curve, AUC. That is nothing but in ROC curve, the area under ROC curve, it is called AUC, area under curve. For example, here AUC is 0.775, this portions where the red in color. So, all other things are same, the true positive rate, false positive rate. What is a good AUC, area under curve? See, maximum it can hold everything, that is the perfect prediction. So, if the perfect prediction is there, that means all zeros are predicted as 0, all ones are predicted as 1, then you will get AUC this full red color. What is a good area under curve? The maximum value is 1 and minimum value is 0.5, it is just guessing one. So, maximum it can go up to 1. Now, we will look for selecting a threshold using ROC curve. We have seen what is the different point of ROC curve, how to choose the threshold value. That was important objective of this lecture. Choose the best threshold for best trade off by looking at cost of failing to detect positive and cost of rising false alarm. It is like a false positive and false negative. We have to see cost of the two, whichever is more dangerous or more costly, that should be minimized. Now, we will explain ROC plot each corners. A typical ROC plot with a few point in it shown in the following figure. There are 4 points there, A, B, C, D. Note that the 4 cornered points are 4 extreme case of classifier. There are different points which are above the diagonal, some points are below the diagonal. We will take each and every points. I will explain what is the significance of these points and how to interpret this point. First, we will look at the point A. Point A is this location. What is happening here? The true positive y value is 1, false positive 0. This is an ideal model, the perfect classifier, no false result. Then we will go to the second category, that is B. Here the true positive rate is 0 because y value is 0, but x value is 1. The worst classifier not able to predict a single instance. Then we will go for C, this situation where true positive also 0, false positive also 0. The model predicts every instance to be negative class. It is an ultra conservative classifier. This will happen when t equal to 1. Suppose if you keep a threshold that is very high level, so everybody will be considered as negative class. The D, this point is true positive rate also 1, false positive rate also 1. The model predict every instance to be positive class. When you take threshold value extreme left hand side, so whoever comes to the pathology laboratory will say that you have the disease. It is an ultra liberal classifier. The problem comes how to choose the right ROC value. Now look at different points inside the ROC curve. First we will look at the points on the upper diagonal region. All points which resides on upper diagonal region are corresponding to classifiers good, because this portion is the good classifier. As their true positive rate is as good as false positive rate, that is false positive rate is lower than the true positive rates. See, there is one point x. when you compare x and z, x is better than z because x has higher true positive rate and lower false positive rate than z. When compared to x and z, x is better. If you compare x and y, see that neither classifier is superior because there is a trade off between TPR and FPR. The TPR is increasing, FPR also increasing. Now let us interpret the different point ROC curve. First we will see the points on the lower diagonal region. Previously I have explained the upper diagonal region. Now we will look at the points in the lower diagonal region. The lower diagonal triangle corresponds to the classifier that are worse than the random classifier, because this side it is not good because it is a high false positive rate. A classifier that is worse than the random guessing simply by reversing its prediction. Suppose look at the 2 point W dash and W. W dash is 0.2, 0.4 is better version than the W 0.4 and 0.2 because W dash is the mirror reflection of W. Now tuning a classifier through ROC plot. See that I have two category of ROC plot. Let us see which is better why. Using ROC plot, we can compare two or more classifier by their TPR, that is a true positive rate and false positive rate values, and this plot also depicts the trade off between true positive rate and false positive rate of a classifier. Examining ROC curves can give insight into the best way of tuning parameter of classifier. For example, in this curve C2, the result is degraded after the point P. You see that the C2, what is happening, true positive rate is increasing, after point B what is happening, true positive rate is decreasing, but there is no much decrease on false positive rate. So beyond this point P it is not giving good classification. Similarly for the observation C1, beyond Q the setting are not acceptable because there is a comparatively more false positive rate when compared to true positive rate. Now there are different classifying, comparing different classifiers through ROC plot. When you look at this picture, see that there are C1, C2, C3. We can use the concept of area under curve as a better method to compare two or classifiers. We can get different classifier by getting different threshold value. If your model is perfect, then the AUC is 1, which I have seen already, which I have explained. If your model simply performs random guessing, then the AUC is 0.5. So this area. A model that is strictly better than other would have larger value of AUC, area under curve, than the other. So out of these three, the C3 is having higher area under curve. So that model and that corresponding threshold value is better to classify which is good or which is 1 or which is 0 when compared to C2, C1. Here the C3 is the best, C2 is better than C1 as AUC, area under curve C3 is greater than AUC, area under curve C2 greater than area under curve C1. Now let us look at our extreme cases of this ROC curve. This was our typical ROC curve. See that how to compare two type of ROC curve. You see that it is closer, the area under curve is somewhat nearer to 1, so it is a good test. When look at this one, area under curve of that ROC curve is lesser when compared to this. So it is a poor test. The left side one is the best test, good test. Now we will see extreme cases. When these extreme cases, see that the two distributions do not overlap at all. In the previously which I am showing two cases, one is true negative and positive, this side true negative, true positive, then false positive, false negative. If the two distributions are not overlapping, you will get very ideal case, that is the best test. the distributions are overlap completely, then you will get this kind of diagonal. This is the worst test. You see that this case true negative, true positive, there is no overlap at all. So, you will get this kind of ROC curve. You see that there are somewhat some overlap is there. So, you will get our typical ROC curve, because there is a area under curve. Previously it was 1, now it is area under curve is 0.7. Now, you see this case, the area, both the distributions are completely overlapping, that whenever it is overlapping, area under curve is 0.5. So, corresponding ROC curve will look like this. So far we have seen and we have understood the concept of confusion matrix and ROC curve. Now, I am going to take one example. That example already I have discussed in my previous lectures. With the help of that example, I will going to tell you how to choose the correct threshold value to classify whether it is belongs to category 1 or category 2. The example is this book, this example is taken from this book, Statistics for Business and Economics, from David, Anderson, Sweeney and Williams. The example is, let us consider an application of logistic regression involving direct mail promotion being used by Simmons stores. Simmons owns and operates a national chain of women's apparel stores. 5,000 copies of an expensive 4-color sales catalog have been printed, and each catalog includes a coupon that provides $50 discount on purchase of $200 or more. The catalog are expensive and Simmons would like to send them to only those customers who have the highest probability of using the coupon. So, what are the variables which are involved in this problem is, one is annual spending, another one is whether the customer has Simmons credit card or not. What we are going to predict, whether a customer who receives the catalog will use the coupon or not. Simmons conducted a pilot study using a random sample of 50 Simmons credit card customers and 50 customers who do not have Simmons credit card. Simmons set the catalog to each of the 100 customers selected. At the end of the test period, Simmons noted whether the customers used the coupon or not. This is the problem. For that problem, this is the data set. Spending, how much they spent the last month, that is our one of the independent variable. Possession of Simmons credit card, if it is 1 he has, 0 does not have, that is the another independent variable. The coupon, whether he has used the coupon or not, that is our dependent variable. You see that dependent variable is 2 category, 0 or 1. So, it is then we have to go for logistic regression. The amount of each customer spent last year at Simmons is shown in the thousands of dollars, and the credit card information has been coded as 1 if the customer has the Simmons credit card, 0 if not. In the coupon column, 1 is recorded if the sampled customers used the coupon and 0 if not. So, we have imported the data. For import, we have imported necessary libraries, import pandas as PD, import matplotlib.pyplot as PLT. Then the data set is simmons.xls. I am going to run this Python code and I am going to explain further. I brought the screenshot of my Python output. So, data.head, we came to know there is a spending is one independent variable, card and coupon. The first one is data.describe, that is to get an idea about the details of each variables. Customer, there is no meaning for this one. For spending, you see that there are 100 values is there, the mean is 3.3, standard deviation is this one. Since card is the categorical variable, there is no meaning for the mean, there is no meaning for standard deviation. So, it is not applicable. The coupon also is a categorical variable. In the categorical variable, there are 100 values is there. Here also there is no meaning for mean and standard deviation, because you cannot do any arithmetic operation when there is a nominal or categorical variable. We are going to use different inbuilt functions. So, if we say data frame dot describe, that function is used to get the basic statistical details such as central tendency, dispersion and shape of the data sets distribution. If you use numpy dot unique, this method gives the unique value in a particular column. The count, this option series dot value underscore counts return object containing count of unique values. This ravel, it will return one dimensional array with all the input array elements. So, I have used that inbuilt function, for example data for the coupon column unique. So, it is giving 0, 1 because that means we can come to know there are two category in the coupon column, one is 0, another one is 1. Then how many, when you say dot value underscore counts, say there are 60, 0, 41. 60 people did not use the coupon, 40 people have used the coupon. Then for running logistic regression and the split the data into two category, some data for training and building the model. After the model is built, we will use the test data to verify our built model. From sklearn import linear underscore model, from sklearn dot model underscore selection import train underscore test underscore split, from sklearn dot linear underscore model import logistic regression. So, the x value equal to data, card and spending independent variable, y value is coupon. Okay. First we are going to split x underscore train, x underscore test, that is the x value after splitting we are going to call it this way, then y train y test equal to train underscore test underscore split x comma y test underscore size 0.25, you can take any value. This I have set some value so that we can repeat the code again, you may get the same kind of output. So, you see that I wanted to say, see for the in the training data set there was 75 data set for x and 75 data set for y. For testing data set there are 25 data set for x, 25 data set for y, this is for testing purpose. First we will use logistic model and we will, after building the model we will predict the values. We are going to use in the logistic regression LBFGS, there are different methods I will show you there when I am running the code. This is one method for constructing the logistic regression model, logistic regression dot fit x train y train dot ravel will return one dimensional array with all input array elements. So, we are getting this output. Now, we will predict the y value by using the test data set. What I have done? We have constructed the model, then we will use the test data set to predict the y value. This was our predicted y value. Then we will predict y value by using the training data set, because training we have 75 data set, for testing there are 25 data set. So, this was after predicting the regression model using training data set. Next one, y underscore probability underscore train, here see that this is the probability value which data set for training data set. So, there are 75 data set, we have got the probability of all the 75 data set. Our problem is going to be there, what should be our cutoff value here to say this below this category is called 0, above that category is 1. So, y underscore probability here also we will find out for using tested data set we will predict the probability. This is there going to be 25 data set, here going to be 75 data set. You see that our task is what should be the cutoff value or threshold value. First we will construct a regression equation, logistic regression, x is x data, y data. After importing the model we got this one, constant is minus 2.1464, spending independent variable is 0.3416, card 1.089. When we look at the pseudo R square it is good, then the p value also good, the overall model is good. Even if you look at the Wald test, so this p value also all are less than 0.05, this model is good. The point is how to set the threshold value. So, after getting this model we have predicted some portions are 1, So, first we will go for checking the accuracy. There are 4 possibility. The actual is 0, predicted 0, it is a true negative. Actual is 1, predicted is 1, it is a true positive. Actual is 0, the predicted is 1, it is a false positive. Actual is 1, predicted is 0, that is a false negative. Because that table is the previous table is the base for the confusion matrix. So, here the accuracy of model is tested by using the score function. So, score equal to accuracy underscore score for y test and y predicted. So, the accuracy of that model is 76. To get the confusion matrix, confusion underscore matrix y underscore test y underscore predict, we are getting this confusion matrix. So, here what is meaning is the true negative is 15, true positive is 4. So, the false positive is 1, false negative is 5. So, this is the way to write the confusion matrix. Generating classification report. You see that when you use this function classification underscore report, you will get this output. This says there are different columns. Say one is on precision, another one is a recall, another one is F1 score and support. This recall gives us an idea about when it is actually yes, how often does it predict yes. It is like our sensitivity. Precision tells us about when it is predict yes, how often is it correct. I have explained what is the recall. So, recall gives us an idea about when it is actually yes, how often does it predict yes. It take care both specificity and sensitivity. If it is 1, we call it a sensitivity. If it is 0, we call it specificity. So, in our problem the specificity is 0.94. That says that see 94% of the time we got 0 and we have predicted also it is 0. When it says sensitivity 0.44, so 44% of the time the actual is 1, we predicted also 1. So, the next one more column is the precision. The precision tells us about when it predict yes, how often is it correct. I will explain this one meaning of precision in the next slide. Now, I will interpret the classification report, which was in the previous slide I have shown that output. The precision is true positive divided by true positive plus false positive. The accuracy is here there is one. So, this cell is accurate value, this cell is also accurate value. So, sum of these two divided by sum of all the cells. So, recall is a true positive divided by true positive plus false negative. In this lecture I have explained graphically what is ROC curve and how to choose the ROC curve with the help of some pictures. At the end I have taken one problem. There in that problem I have explained what is the confusion matrix, how to interpret each cell in the confusion matrix. The next class we will continue and I will explain how to choose ROC value with the help of this same example that we will see in the next class. Thank you.